Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Nuratnamika Swani. So today I will present on PSM1 titled Ergonomic Risk Assessment of Athlete Using Ergometer Rowing Machine, an Advanced Assessment. So my supervisor for this project is Dr. Salwa binti Mahmud, and my co-supervisor is Dr. Amirul Syafiq bin Zadun. So in this slide presentation, I will explain on Chapter 1, Chapter 2, Chapter 3, and Chapter 4. So we will go for the Chapter 1, which is introduction. In this introduction, the background of this project is about rowing. One of the sport is most technically and physiological skill. So this rowing is related to ergonomics, which is ergonomics, sometimes we call human factors, which is analyze the interaction between humans and other system elements, and is a profession that designed to improve human well-being and system performance. So ergometer is one of the stimulation on land for rowing training before going for on water training. So there is two type of ergometer, which is dynamic and stationary ergometer. As we know, for this project, is critical to have an appropriate posture and proper procedure when using ergometer to reduce ergonomic risk factor. This project examines ergonomic risk factor of rowing without adequate techniques, which may lead to injury for retention rowers. Rowers may get musculoskeletal disease and repetitive strain injuries if have a bad posture. So using REBA and a motion sensor, rowers can enhance their ergometer posture. A preliminary concept for this project exercise posture includes an ergonomic review. So we will proceed to the problem statement. In this project, the problem statement are: rowers often experience cumulative trauma disease and low back pain for improper ergonomic posture, which is a bad posture in ergometer rowing machine. So there is a lack term of ergonomic risk factor for rowing ergometer machine that needs to be studied further. So the majority of novice rowing or beginner athletes are unable to have an ergonomic posture on ergometer rowing machine. So this project is to propose an initial and advanced era because it is suitable for rowing ergometers and can analyze ergonomic risk factor. In addition, using a motion sensor will improve a rower's ergonomic posture, which requires a greater ergonomic risk assessment and analysis. Poor ergonomic posture will increase the risk of slip disc in the back and knees. So the objective for this project is to conduct an initial era among rowing athletes at UTSM. The second one is to perform an advanced era for rowing athletes at UTSM. The third one is to implement a motion sensor device capable to guide beginner rowing athletes at UTSM. So the scope for this project is a REBA worksheet was developed in accordance to DOSH. It was used to analyze rowing posture and movement using advanced era, advanced REBA, and motion sensor approaches. So the height we selected for this project is in range of 155 centimeter to 185 centimeter. So apply the REBA technique for implementing positioning of motion sensor. The significance of this project is to increase awareness about the ergonomic risk factor associated with rowing athletes. As an alternative way, applying a motion sensor is to help the athlete maintaining proper posture during using ergometer rowing machine exercise. Next, we go for expected outcomes. What we expect from this project is to increase awareness about ergonomic risk assessment and deploy ultrasonic sensor to improve rowing athletes' ergonomic posture. Because this sport is use whole body, so appropriate rowing posture is needed to decrease physical and mental stress. Therefore, the era will train athletes the importance of good posture and how to improve their performance via a motion sensor. This motion sensor device can guide athletes a good posture, ergonomic posture in ergometer rowing machine. So we go for the next chapter. Is chapter 2. It is about literature review. So in this literature review, there is some of previous case study. I have go through. The first one is about postural analysis using Rula and REBA. The thesis is from Ansari and Sheikh. They found that Rula determined the most workers were high risk and needed immediate change. So the most workers were at high risk. Postural research by Rula and REBA demonstrate overwork, bad posture is a common. In the next thesis, it is a REBA in terms of development, application, validity, and limitation by Al-Madani and Abab. The final result found REBA is useful for postural assessment in industrial health and care, construction, so mill task, retail food, computer-based occupations, packing, school workshop, odontological service, firemen, and MTS. The method zero backs did not stop its development. It is still used and has computerized checklists and public domain tables. The next thesis is study on analyze while rowing on a rowing machine using initial sensors. So the study is a comparison between experienced, beginner, excellent, and then technical work. So machine learning to compress our work as a reference to our work. The next case study is about ultrasonic motion detector. It is by Murtala Zunderu. It's find that the design sense enclosed motion. In this work, a transmitter transducer generates 40 kilohertz signal that triggers a buzzer through a timing circuit. This system relies on signal interference from an intruder or moving object. Design installation fulfilling standards. Moreover, Just and Kumar have studies on 5 economic risk assessment tools, which is RULA, REBA, American Conference of Governmental Industrial Hygienists Threshold Limit Value, Strength Index, and Sachin's Exposure Index, OCRA. So the final result found that a percentage of perfect agreement varied by employment. RULA and SI work the base, the correct classifications, rates of 99 and 97% respectively. So the next case study is about economic risk assessment tools include quick exposure check and AREBA by Mutamezad. It is fine that to apply approach have associated final ratings and action levels. So comparing action levels and final score of the approach, it shows no departmental differences. So next case study is use 3D skeletal modeling to imitate human body movement in an actual construction manufacturing plan for economic risk assessment of a workstation. So the final result found that 3 subjects are used to compare joint angle, body segment risk rating, and REBA or RULA of a risk rating and a risk level. So Anju going for studies on ultrasonic sensor measure the distance of target object or material through air using non-contact technology. It detects an obstacle's distance. Then the inbuilt analog to digital converter is calibrated to measure a distance accurately. LCD panel is a display measure distance. So based on Mustafa Gabriel and Paul Kuria's case study on Arduino Uno microcontroller, ultrasonic sensor, passive infrared sensor, and many others to sense and measure a distance. So the test revealed the suggested sensor could accurately measure distance and display it on LCD. The sensor emits sound signal on a sound buzzer and display visible LED indicates for a distance less than 150 cm, 70 cm, and 40 cm. This way of measuring distance is accurate. Enterprise and traffic agency utilize the distance sensing and measuring for proximity detection. Last but not least, the previous study about diagnosis, prevention, and main risk factor of MSD are analyzed based on literature search and vital statistics. So its final result found that primary prevention focused on risk assessment and implementation of technical, organizational, and person-oriented measurements. Secondary prevention consists of targeting, early identification, and intervention. And a tertiary prevention aims to stimulate and facilitate the return to work process of MSD affected works. Next, we go for a methodology for this project. The methodology of this project we will conclude in this flowchart from the start of this project until the end of this project. So, start for this project, we will go for research background of study about economics, about sensor, about rowing motion, and others. Next, we go for selection of rowing question. This question it is include the posture, how we can analyze the data for the athletes. Then we go for the posture. Then we collect the data by using a videos or figure for the assessment. After that, we will conduct an initial error, and and if it need for an advanced error. If yes, we will conduct an advanced error. Then if no, we will proceed to the prepare assessment report. Next, after conduct the advanced error, we will apply a motion sensor to detect ergonomic posture on ERGOMETER rowing machine based on the level risk or after conducting an advanced error. If no, we will going back to the research background of this project to find the suitable method to analyze the data for the rowing athletes. Then if yes, we will prepare for assessment report, and it is end for this project. So next, we will go for initial error checklist. So there is 9 risk factor for initial error, which is included awkward posture, static and sustained work posture, forceful exertion, repetitive motion, vibration, lighting, temperature, ventilation, and noise. The result of initial error, if it's a high from the minimum required, we will go for the advanced error. So next, we go for the REBA assessment. This REBA assessment is an advanced error after exceed the minimum requirement for the initial error. So an advanced error included six part of body, which is neck, trunk, leg, upper arm, lower arm, and wrist. So this table we will use for calculating the posture of the rowing athletes. Next, we will go for the procedures to use the table of REBA assessment. So the first thing first, we will identify the rowing posture. In this project, we will choose the 4 posture, which is from catch, drive, finish, and recovery. So the REBA start with the rowing posture. So the audiovisual and pictures recording equipment were used to capture side view image. The best posture was chosen and in charge. Long head posture incurred the most for slot. The next is core workout activity and calculate the final score. The REBA combines postural group, which is section A include trunk, neck, and leg position. Section B include lower arm, upper arm, and wrist. The posture was determined using table A from the REBA assessment worksheet. And table A boosts force, assess upper arm, wrist, and lower arm. Each posture is rated based on deviation from neutral. Using table B from REBA assessment sheet, aberration score is calculated. Then add the table B value to muscle use and force. The table C, which shows an A and B score. And the final score for table C is an REBA score. So the next one is we consider the action level. After calculating the REBA, MSD and exposure risk using the final score. Final score can be defined action categories, which is include 5 categories, and REBA evaluation measure work posture risk. So these 5 categories include, the first one is 1 is F. If the number is from 2 to 3, we will implies a low risk, and 4 to 7 needs change. 8 to 10 is a high risk and need further study, and 11 and above mean high risk and require a solution or proposal. This one is the REBA example of the REBA score sheet for calculating REBA score. So this sheet is we will refer for REBA assessment sheet to how to calculate this REBA sheet. We will get the final score for the REBA score, and going for the next is consideration the level of risk. So this one is the level of risk as I mentioned before. There is 5 level. The first one is 1. The level of MSD risk is major level risk, no action required. If the REBA score is in between 2 to 3, it is a low risk and change may be needed. And if 4 to 7 is a medium risk and further investigation needed, and 8 to 10 is a high risk, need to investigate and implement change, and if 11 and above, very high risk and need to implement change. So next we go for the block diagram for this project. The block diagram for this project, we have ultrasonic sensor, infrared sensor 1, infrared sensor 2, module Wi-Fi 1, module Wi-Fi 2, and LED green and red. So the block diagram position. So in this project, the IR sensor detect the chest. So the infrared sensor will be used to detect a chest, and this sensor will assess arm performance during a rowing. Wi-Fi module 2 will act as a controller that receives a signal from infrared sensor 1 and process the data and send to Wi-Fi module 1 via Wi-Fi signal. Wi-Fi module 2 is turned on using a 5-volt battery. So the ultrasonic will detect distance traveled by the athlete, whether the seat exceeds the proper distance to get the performance of the rowing exercise or not. So the Wi-Fi module 1 is processed the all data obtained from the 3 sensors. So ultrasonic will be placed on the seat at the ergometer rowing machine, as shown in the picture in the slide. So next, this is the flowchart process of the sensor react in this project. So the first thing first, we will choose a height range in between 155 to 185 centimeter. Then the rower will start to the exercise. So if the rower is doing a good posture, the infrared sensor 1, infrared sensor 2, and ultrasonics will green LED will light up, which is the infrared sensor 2 detects the leg, infrared sensor 1 detects the chest, and ultrasonic will detect the proportionality of distance. So if no, it will turn to red light LED, and the rower need to improve the posture at the ergometer rowing machine. So that is the process how the sensor detect a proper ergonomic posture on the ergometer rowing machine. So last but not least, we will go for the data analysis and the result. So what we expect from this project is this design can assist a rower in a training more effectively and with discipline. Rowers who have potential but not currently rowing athletes will quickly adapt to a rowing movement and posture, allowing them to acquire a high degree of physical fitness. Then the sensor will also accurately detect the athlete's body based on REBA method. The sensor will also properly identify the athlete's body position. In addition, athletes are also capable of performing rowing exercise with discipline and effectiveness. I think that's all for for my presentation. Thank you.